Hello everyone, I'm Remus Arconanan, and in this video, you will learn how to draw the Lewis dot structure in 5 steps. But first, what exactly is a Lewis structure? The Lewis structure is a simplified representation of the valence shell electrons in a molecule and was introduced by Gilbert and Lewis. It shows how electrons are arranged around the atom. In the Lewis structure, the electrons are represented as dots, or for bonding electrons as a line. The octet rule. It is a chemical rule of thumb that refers to the tendency of atoms to prefer to have 8 electrons in the valence shell. Note, hydrogen and boron are an exception. Hydrogen only needs 2 electrons and boron atoms only need 6 electrons. Valence electrons. Valence electrons are electrons on the outermost shell or energy level. To find the valence electron of an element, you just need to look at which group or column they belong in. For example, is oxygen. Oxygen has 6 valence electrons because it is on the column 6. And here are the steps in drawing the Lewis dot structure. First is count all the valence electrons. Next, determine the central atom, and the central atom is the element with the least amount of atom. Third is draw single bonds to the central atom. A single bond is a pair of atoms. Fourth, put all the remaining valence electrons on atoms as lone pairs. And fifth is turn lone pairs into double or triple bond to give every atom an octet or duet. And now, let's apply all of these steps. For example number 1, we have NH3 or ammonia. So as the first step says, you have to count all the valence electrons. So N or nitrogen has 5 electrons and 1 atom. And we will multiply them and we will get the answer of 5. Then H or hydrogen has 1 electron and 3 atoms. And we will multiply and the answer will be 3. And we will add both of them and the answer will be 8. Then for the second step, we need to find the central atom. And it is nitrogen or N, because it has the least amount of atom. And we will write it correspondingly. For the next step, we need to draw single bonds to the central atom. Like this. As the fourth step says, we need to put the remaining valence electron, and we still have 2 remaining electrons. We will put it in the nitrogen atom because it is still not stable or satisfied. We have now used up all of our remaining valence electron, and all of the atoms are both stable and satisfied. So we can skip the 5th step. NH3 is a single bond. Next example is CO2 or carbon dioxide. First, count all the valence electron. Carbon has 4 electrons and 1 atom, and the answer will be 4. Oxygen has 6 electrons and 2 atoms, and when we multiply, we will get the answer of 12. By adding the both of these, we will get 16. Next, we will find the central atom, and it is carbon, and we will write it as so. Then, we will draw the single bonds to the central atom. With these single bonds, we have now used up 4 electrons, and we have remaining of 12. For the next step, we will put all the remaining electrons as lone pairs. We still aren't finished because carbon is still not stable. Now, we will make double bonds. We will take these electrons and make a double bond with them. And now, all of the atoms are stable and satisfied. and CO2 is a double bond. And here is example number 3, CO or carbon monoxide. Let's count the total valence electron. Carbon has 4 electrons and 1 atom. The answer will be 4. And oxygen has 6 electrons and 1 atom. And the answer will be 6. By adding this, we will get the number 10. This chemical bond only has 2 atoms, so there is no central atom, and we can skip that step. Then we will draw the single bonds between them. And with that, we've used 2 electrons. Then we will put the 8 electrons that we still have as lone pairs. But we still aren't finished because oxygen atom is still not stable. We will take these electrons and make a triple bond. And now, all of the atoms are stable and satisfied. And we are now finished. And CO is a triple bond. And that's it for me. And I hope everyone learned something, and thanks for listening. Bye!